Thanks very much. I've been coming to these things for years, and I keep saying to Leo, if you wear multifocal lenses, you can't read the screen, Dad. Where's Leo? I guess it'll fall on deaf ears again. Anyway, what are we going to go through today? First of all, I'll take you through the energy metal cycle. I'll tell you about process improvements. It'll give you lower emissions, lower cost, and product recycling, which I think is a critical issue today with tight supply on commodities such as lithium and cobalt. I'll tell you a little bit about disruptive technologies that may close the loop so we can go from primary production into batteries, right around recycler batteries and get them back into materials to sell to the public. I'll tell you a little bit about comparisons with other approaches. One example in Germany that we're currently working on, and close off by showing you how you use this range of technologies to go from mine waste right through to battery cathode materials. So the first thing we need to do is have a look at the energy metals cycle, and there it is. And Lithium Australia's aim is to close that loop to improve the sustainability of those metals that we use in lithium-ion batteries. You'll notice there a number of proprietary technologies that we're working on. There's the silage process, 100% owned by Lithium Australia, VSPC, which is cathode material production, company that we're actually buying to get hold of that technology. And then if you go through that cycle and get to the grey bit, that's where batteries exit and go to landfill under most circumstances. Globally, less than 10% recycled. In my country, Australia, less than 4%. The interesting thing about that, of course, is someone spent a lot of time, effort, mining, refining, creating a very pure product, putting in a battery. You use it and then you throw it away. And I imagine just about every one of you here has got a spare mobile phone somewhere that you haven't recycled. And the same happens with a lot of other bits of personal equipment, computers and the like. So what we want to do is capture that stream material and get it back into the processing cycle, thus improving the sustainability. And hopefully long term, as this sort of approach becomes adopted by the industry, and it simply has to be, we will take some pressure off primary production by doing these things. So the technologies that we're fusing together to do that, there's the silage process that we've been developing over a number of years with very strong partners, including the Australian government, ANSTO in particular, the Australian Nuclear Science and Technology Organisation, who partnered with us to develop the intellectual property, of which we own 100%, I might add. Then we've got VSPC, which is the cathode production technology, and it's quite interesting because conveniently, we won't do it immediately, but our long-term aim is to bolt it straight on the back of silage. So rather than delivering to a battery producer a product that he doesn't want, which is lithium carbonate and lithium hydroxide, which he has to recycle in any case, he needs to produce other chemicals out of it, being the cathode materials. Why not just deliver them the cathode materials they want in the first place? And then we've got RCARC, Resource Conservation and Recycling, to bring those materials back and stop it going into landfill. And then we've got underpinning this business an exploration portfolio, which to a large extent is our insurance policy. The silage technology has been designed primarily to take the two hard materials and process those. And those materials are things like substandard spodumene concentrates and lithium micas in particular. The silage process advantages are no roasting, so it's got a low energy footprint. It does completely dissolve the minerals that are subjected to that processing. There's a hydromet process that starts off with sulfuric acid and the addition of calcium fluoride to make these minerals dissolve. And then when you've done that, you have all the components of those minerals in solution, so you can take any of those components and turn them into valuable byproducts and get a byproduct credit. So the driving forces behind this from a commercial point of view is low energy footprint and access to a significant range of byproduct credits. That's what gives you the low operating cost, and we have proven this on pilot scale and produced lithium-grade chemicals inside a laboratory at Anstow in Sydney. So those cost advantages, when you have a look at them, the grey line is the median cost of carbonate production from the hard rock producers. When you take into account a lower energy footprint, you lower that cost to some extent, and then with byproduct credits get down to the sorts of levels we hope we will get down to the sorts of levels that are comparable with the brine producers. The other technology that dovetails with this is VSPC, very small particle company, and what this process does is takes the lithium in solution with the other metals that you have to produce cathode powders, and by doing a couple of incredibly simple things, take those metals out of solution and create a powder. And it's done by generating a hydration sheath around a flocculant. You effectively dial up the chemistry of the cathode that you want in solution. You then produce a flock with an organic flocculant, and then you calcine the flock. In doing that, you produce exactly the same chemistry in your particles all of the time, and by controlling those flocculating agents, you can control the size. So you effectively dial up the size, dial up the chemistry. The problem with conventional production is a lot of it's done in solid state, revolves around mixing, sizing and what have you, and it tends to lack a little bit of quality control. So the acquisition of this company will certainly give us a fast track into the production of cathode materials, and something that will dovetail with the other processes that we've been developing. Now, RCARC, well, I think I've said it all. It's all about recycling material that would otherwise be thrown away, and it is process compatible, which is most important with silage. And if we can implement this, it gives us first mover advantage. An interesting situation in Australia, which could potentially create, by way of legislation, a monopoly, but that's another story. But it's a great position to be in. The base case is designed around generating products of the largest common battery flow that you've got in recycled materials, which in fact are the alkaline batteries, and they're going to be mixed, of course, with lithium-ion batteries when you process. A case in point of taking waste materials and turning them into ore by using the silage process. This is Sadersdorf, which we have in joint venture with Deutsche Rohstoff in Germany. Sadersdorf is a mothballed tin deposit. Won't run on today's tin grades, but if you can add back the lithium credit, it's quite significant and will allow you to tack that process onto the back end of a plant that would normally give you tin and tungsten credits, and then pull out of the waste material all those other elements. So that effectively is breathing new life into a European mine. Now, if you look at the whole production train, where's the sweet spot? If we produce lithium carbonate, $1,000 a tonne. If we turn that carbonate into cathode material, it generates 5 tonne of cathode material, which sells for about $35,000 a tonne for each tonne, and there are 5 tonnes of it. So it gives you an uplift of about 15-fold. That's where the sweet spot is in the value chain, and that's where we intend to place ourselves long term. So we are the only company in the world with the capability of taking mine waste and taking it right through to battery cathode materials, and a little bit further down the track, recirculating the whole lot of that by recycling those lithium-ion batteries. So why invest in Lithium Australia? We've got, I think, some of the best technologies available in the lithium industry. We've thought outside the box to develop those. We can produce lithium cathodes. We can produce cathode precursors such as carbonate, hydroxide, etc. We've got world-class technology in silage, the same with respect to the production of those cathode materials, and the only company with access to all of those technologies for full integration. And clearly we have a fairly experienced management team, you can tell, because we're starting to run out of hair. The valuations on this slide are so far out of date because they were produced on the 1st of February before the markets took a bit of a hiding, so market capitalisation's down about 25% with respect to the numbers shown on those slides, but unfortunately I had no time to amend them this morning. So that's the story. It's all about sustainability in the battery industry and taking a fair bit of pressure off primary production. Thank you.